Okay, welcome to Module 4, Lesson 4. By the end of this lesson, you're going to be able to write and solve equations that relate to geometry. You'll know you're successful today when you can apply your knowledge of geometry to write and solve equations. We're going to go review some geometry skills, just some like basic geometry knowledge. I'll go through some examples with you. You'll complete your exercises. We'll kind of close out the lesson, reflect on some things we learned, and then complete the exit ticket. Alright, so before we get into this lesson, we need to review some things from geometry that you've learned in the last couple of years. That you'll need to know these things before we get into writing equations today, because these are actually like the clues that we get that allow us to write these equations. So the first one I'm going to go over with you is complementary angles. So a complementary angle, this is when two angles add up, two or more angles add up to 90 degrees. Okay, and I'll just show you like a little example of that real quick. So say I have a 90-degree angle, and then I have this split like a couple ways. Angle 1, have that in red. Angle 2, have that in green. Angle 1 and 2 would be complementary. Okay? Moving on, we're going to talk about supplementary angles. So supplementary angles add up to 180 degrees. And a lot of people get complementary and supplementary mixed up. The way that I figure it out is I just say, okay, well, supplementary, that's a longer word. So it's a bigger word, so it adds up to a bigger angle. So supplementary angles add up to 180 degrees, and 180 degrees is a straight line, okay? So I'll give an example of that here. Let's just say we have angle 1 right there, and angle 2 right there. If we added those angles up, you can see that it creates a straight line, or it adds to 180 degrees, okay? Adjacent angles. Adjacent angles are angles that are directly beside one another, okay? So they could also be complementary or supplementary, but they don't have to be, okay? So these two angles, call it angle A and angle B, those are adjacent. These two angles, angle A and angle B, these are also adjacent. So it's angles that are directly beside one another. Okay. Then we're going to get into triangle. We should all know what a triangle is, but there's definitely different kinds of triangles. All triangles add up to 180 degrees. Okay? So the angles within a triangle always add up to this. If it's an equilateral triangle, that means they're all the same. That means that each angle would be 60 degrees. Okay? If it's a right triangle, then we know there has to be one right angle, which would be 90 degrees. And then these two would kind of be easier to figure out because you can just take 90 away from 180, you figure out what you have left. And there's other types of triangles as well. We'll get into that when we talk about geometry, but the main thing I wanted you to realize is that the angles within a triangle add up to 180 degrees. Okay? Quadrilateral, this is any four-sided figure. We have like rhombuses, not triangles, rectangles, squares, but the angles within a quadrilateral four-sided figure all add up to 360 degrees, always, okay? Congruent, when something is congruent, that's a sign we'll be using, but when it's congruent, that means that they have the same measurements, so it's pretty much equal in size, okay? A straight line, we kind of talked about this earlier, but a straight line, the measurement of that angle of a straight line is 180 degrees. So anytime something makes a straight line, it equals 180 degrees. All right, here's where we get into something a little bit more technical. So we have alternate interior and alternate exterior angles. Basically what this means is that there has been a set of parallel lines. So here I'm just drawing in red some parallel lines, and they've been cut by a line, okay? And we call that line a transversal, but we'll get to that later. Now when this line cuts it, it forms stuff on the interior or the inside. The inside of those parallel lines, and it also forms things on, or angles on, the exterior. So this is the exterior or the outside, and then this would be the exterior up top too, on the outside of those parallel lines, okay? Now if we're talking about alternate angles, it's like on the opposite side. So think about like alternating. So here we have, let's just call this angle A. The alternate angle to the angle A right there, the alternate interior, so it's going to be opposite side but still inside because it's still interior, would be that right there. Those are alternate interior angles. And alternate interior angles are equal. Okay? Now if we did the same thing but we looked at exterior angles, let me change my color a little bit. Exterior angles, it would be alternate exterior, so they'd be on the outside. Let's call this C and D. So they're alternating, but they're on the outside. And again, those are equal. Okay? And then the last thing we have here is vertical angles. So vertical angles are, say I have these lines crossing each other. Vertical angles are the angles that are formed across or vertically. There's angle A, there's angle B, and these vertical angles that are formed are also equal. They always equal the same. And you could do vertical angles this way too. They would always be equal. So that's just to review some terms with you before we get into the lesson, because we'll need to know these things when we start doing our math today. Basically, we're going to be using these numbers, 360, 180, or equal signs, to write our equations and then to solve them. We're going to hop right into our first example. As you can see, these are word problems, and we always want to make sure we close read our word problems. So you will be close reading today, okay? First time I read for the big idea. One angle is 5 degrees less than 3 times the measure of another angle. Together, the angle measures have a sum of 143 degrees. What is the measure of each angle? Ready for the big idea? This time that I read, I'm going to be annotating. I'll be writing things in, circling things, etc. One angle is 5 degrees less than 3 times the measure of another angle. So this is going to be that first angle that they're talking about. And it tells me all about it. Okay, it says 5 degrees less, so I'm going to be taking away 5 degrees. Taking away 5 degrees from 3 times the measure of the other angle, so whatever the other angle is. Okay, together, so if we take that first angle and then this second angle, together they have a sum of 143 degrees. So when I add up my first angle plus my second angle, it equals 143 degrees. And the question that it's asking me today is, what's the measure of each angle? Okay, I read for the second time, did some annotation, mark my second box. Third time I read, I'm going to actually be trying to find my variables because I want to define those as I go. Okay? One angle is 5 degrees less than 3 times the measure of another angle. Do I know what this angle is? No, I do not. That's going to probably be a variable. Do I know what the other angle is? No, I do not. So that's going to be my other variable. So it looks like I'm going to have 2 variables here. There's 2 things I don't know. Together they have a sum of 143 degrees. What is the measure of each angle? So that's what I'm trying to find out. That's going to be my variable here. All right, so I'm going to get started with this. I'm going to write in red. And just to start, I'm going to basically say angle 1 plus angle 2, I don't know what these are yet, equals 143 degrees. Okay, that's what I'm starting with. That's the most basic thing I understood from this problem. Now, I got to figure out what angle 1 is and what angle 2 is based on the clues they give me. Okay, so let's do angle 1. Let's call angle 1, let's call this A. And let's call angle 2 B. Okay, so far I have A plus B equals 143. All right, let's look at angle A first. So it says, this angle is 5 degrees less than 3 times the measure of another angle. So it's 5 degrees less than 3 times the measure of the second angle. So A is going to be 5 degrees less. So I just wrote minus 5. Then, so it's going to be less than something. We're taking away this 5 degrees from 3 times the measure of that other angle. So 3 times that measure of angle B. I don't know what measure of angle B is yet, so I just have to use the B. So angle 1 is 5 degrees less, I have that, than 3 times the measure of angle B, that other angle. Cool, so I have that written down. It doesn't give me any clues about that other angle, so I'm just going to keep angle B, okay? And together they equal 143 degrees. Now you'll see real quick that I took my original equation that had an A and a B, it had 2 variables, and I turned that into a one variable equation, okay? I was able to take the clues they gave me and rewrite that so it said B instead of A. So now I can get to solving this, all right? And this is what we did yesterday. Draw a line through my side, combine like terms, etc. So I'm going to add 5 to both sides. I get 3B plus B equals 148. Okay? Let's zoom out a little bit. I'll continue. 3B's plus 1B is 4B's equals 148. Now to get B completely by itself, I just have to divide by 4. Divide by 4. And then on this side it cancels. I'm left with just B equals 148 divided by 4. Now I could try to do this in my head, but I'm just going to do it on my calculator. You can also work it out on paper, but we all have access to calculators. So 148 divided by 4 equals exactly 37. Cool. So you would think you'd be done, but my question asked me for the measure of each angle. I just found the measure of angle B, right? So now I know that angle B is 37 degrees. Here's what I'm going to do. I'm going to go back to my original thing up here. Angle 1 plus angle 2 equals 143. And now I know that angle B is actually 37 degrees. So I have angle A plus 37 equals 143. And I'm going to solve this problem off to the side. So we have A plus 37, sorry this got so big, is 143. And now I'm going to solve for A. I'll take 37 away from both sides. And I get A equals, do our math here, 4, 3, 13, 6, 0, 1. A equals 106 degrees. How could I check this? I could add them both up, right? I could say, is B plus A or A plus B 143? And if it is, then I was correct. So 106 plus 37, we have 13, 4, 1, and my answer checks out. Moving right along to example 2, I'm going to make my 3 boxes to do my close reading. First time I read, big idea. Given a right triangle, find the degree measure of the angles if one angle is 10 degrees more than 4 times the degree measure of the other angle, and the third angle is a right angle. read for my big idea. This time that I read, I'm going to go in and mark it up a little bit, annotate. Given a right triangle. So one thing I know about a right triangle is that it looks like this, right? It's going to have a 90-degree angle. I know that all of the angles inside a right triangle add up to 180 degrees total. Okay? Find the degree measure of the angle. So I'm going to try to find all three of those angle measurements. If one angle, the first one, is 10 degrees more than 4 times the degree measure of the other angle. So let's just call this first angle, angle A. Okay? And the third angle, oh sorry, we also have the other angle. So that's angle B is our other angle. And the third angle is a right angle. So see, that's 90 degrees. That'll be our easy one. Okay, one more thing I'm just going to add in for this angle A. It's 10 degrees more, so we're doing plus 10 somewhere, then 4 times the measure of the other angle, which was B. So A is 4 times B plus 10. All right, I've read for my second time, mark my second box. And I've already kind of done this, but I'm just going to reiterate it as I go. The third time I read, I'm going to be defining my variables, that kind of stuff, and making sure I know what represents what. So given a right triangle, find the degree measure of the angles. If one angle is 10 degrees more than 4 times the degree measure of the other angle. The third angle is the right angle. So I have 3 angles. A, oops, that's too big. I have A, B, and C. 3 angles, and together they make a right triangle, which I know all triangles equal 180 degrees. Okay? Right off the bat, I know that C is 90 degrees, so I can change that variable to 90 degrees. Okay? That's pretty cool. And then I have A and B. So A is actually 10 more than 4 times B. So I can turn this A into exactly what I just said. Instead of writing A, I can write what it has told me, that this is 10 more than 4 times that other angle, which I decided to call B. Okay? And the only thing I haven't copied down yet is this plus B. So you'll see that I've changed a few things in my equation so far. I changed my C to 90 degrees because that's no longer unknown. We know what it is. And I changed my A to what I do know. I don't know everything, but I know it's 10 more than 4 times B. Okay? Now that I'm this far, I can go ahead and solve because as you can see, I only have one variable. We always have to break it down and get one variable before we can solve. We can only solve for one variable at a time. Later we'll figure out how to do more, but right now we only know how to solve one variable at a time. All right, so I'm going to just combine my like terms over here. 4 b's plus 1b is 5 b's. And I still have my 10 and my 90 equals 180. Okay, scoot down a little bit. Now I am going to combine my numbers on this side. 90 plus 10 is 100, so I have 5 b's plus 100 equals 180. All right, trying to get b by itself right now. There's a plus 100 beside it, so I'm going to take that away. So it's no longer there. If I do it to the left, I have to do it to the right. Over here it cancels. I'm left with 5b equals 180 minus 100 is 80. And then to find b, I'm just going to divide by 5. b equals 5 goes into 8 one time with 3 left over. 3 with that 0 is 30. So that would be 16. So again, I'm not done with this because I only found out what b was. I still have to find out what a was, what a is, okay? So I need angle A, B, and C. So we knew C was 90 degrees from the beginning. We just found out that B is 16 degrees. We got to find A. So we know that A is 10 plus 4 times b. So I can just plug that in. A equals 10 plus 4 times b. Now we just solved for b, so I can plug that in now. B is 16, so this is going to be 4 times 16. Okay, we can do that in our calculators. 4 times 16 is 64. And then we're just going to add our 10 to that to find a. 10 plus 64 is 74. So I found that a is 74 and b is 16. How could I check this? I could add these all up. What should they add to? They should add to 180. And I'll do that real quick. 74 plus 16 plus 90. 4 plus 6 plus 0, 10. 9 plus 1, 10, plus 7, 17, plus 1, 18, and 180 degrees. This is my answer. All right, example 3, draw my 3 boxes for close reading. A pair of alternate interior angles are described as follows. One angle measure in degrees is 14 more than half a number. The other angle measure in degrees is 6 less than half that number. Are the angles congruent? I read for my first time. This time I go through, I'm going to be marking it up a little bit. I'm actually going to zoom in a little bit more. A pair of alternate interior angles. What do I know about alternate interior angles? They're equal. They're the same. So 2 angles are the same. Okay? One of those angles, so let's just say the first one is 14 more than half a number. 14 more, so plus 14. What is it, 14 more than? Half a number. Does it tell me what the number is? No, so I'm just going to say 14 more than half of n. Okay? The other angle is 6 less than half that number. So this other angle is 6 less than whatever that number was, divided by 2. Okay? Are the angles congruent? What does this mean, congruent? This means, are they the exact same? Are they equal? Okay, let's go ahead and mark my second box. I did my annotations. This time I'm going to actually start writing some stuff out, find my unknowns, that kind of thing. Okay, so we have 2 angles. They're alternate interior angles. One angle measure in degrees is 14 more than half a number. That number, I don't know, so that's what I've used as my variable right here. Okay? Half that number plus 14. That's my first angle. The other one is going to be 6 less than half that number. Again, we don't know what that number is. I use that as my variable right here. Are the angles congruent? So we want to set this up and see, will the left side equal the right side? Will these 2 angles balance out to be the same? All right, so we have 2 angles. Let's just call them A and B. Let's call this A, and let's call this other one over here in green B. So together, they should equal one another because they're alternate interior angles. A equals B. Now A is 14 more than half some number. So A equals, it's the same as 14 more than n divided by 2. Okay, I just changed that A to exactly what it told me A actually equals. B is 6 less than n divided by 2. All right. So now that I have my problem set up, I am going to solve. The first thing I want to do is get rid of this 2. That is the denominator, and it's really cool. It's easy here because they have the same denominator. So what I'm going to do to both sides to get rid of it is times by 2. Okay. 2 times 14 is 28. Keep that plus sign, and then 2 times n divided by 2. Those 2's cancel out, so this is just n. On this side, 2 times 6 is 12. 2 times n divided by 2 is n. We keep our subtraction sign. All right, so I have 28 plus n equals n minus 12. Now I'm just going to add 12 to both sides. Over here it cancels. I'm left with n equals 28 plus 12 is 40. 40 plus n is where I'm at right now. Move down a little bit. Now I want to move this n to the other side. I take away an n. I take away an n. Over here it cancels. Over here it cancels. What the heck? Nothing's left. And then we have 40 equals 0. I'm going to give you a second to think about this and what does this mean for what I've just done. So what we learned earlier in Module 4 Topic A was that if this does not work out, if this is not true, then our solution is not correct. So are the angles congruent? No, they can't be. And the reason being is that we could not find a solution to this. There was no solution, so something along the way could not be possible. Okay? All right, now that we're done with our examples, you're going to get started on your exercises. You can see that you have 6 here, but I'm only going to make you do numbers 1, 2, and 3. Again, you don't need to do 4, 5, and 6, okay? Make sure you do your close reading on each, and you are using those things we learned about geometry to help you through this to solve for your variables. Pause the video right now, and then go do 1 through 3, and then when you're done, come press play so you can watch yourself. So at this time, you should have solved these problems on your own. I'm now going to go over the answers to them, starting with number 1. A pair of congruent angles are described as follows. The degree measure of one angle is 3 more than twice a number. 3 more than twice a number. And the other angle's degree measure is 54.5 less than 3 times the number. So 3 times that number, we're doing 54.5 less than that. Determine the measure of the angles in degrees. So what you are doing right now is you're setting these two things equal to one another because it said that they were congruent. Now I'm not doing my close reading completely right now because you should have done that on your own. But basically we have 3 plus 2n equals 3n minus 54.5. And we are going to solve this right now. The first thing I'm going to do is add 54.5 to both sides. Do you have to do this first? Absolutely not. You can solve it in whatever order you want to. Like I said though, as you get better with math, as you become more confident, you'll know what steps are easier to do first. And in my opinion, that was the easiest thing to do first. Okay? So 54 plus 3, 55, 56, 57.5 plus 2n equals 3n. Next thing I'm going to do is I'm going to take 2n away from both sides. I get 57.5 equals 1n. You could put the 1 in front of it, but you don't have to. So, I now know what this n represents, but I don't know what my two angles represent. So I'm going to have to apply this to both this first expression I came up with and this second expression I came up with to get my answers. So I'm going to start with this first one right up here, 3 plus 2n. This now becomes 3 plus 2 times 57.5. Because that's what I got for n. Okay? So if I do this in my calculator, 57.5 times 2, I get 115. So this becomes 3 plus 115, and that becomes 118. So this is the measure of my first angle. And then I'm going to do the second one right here. I now have 3, instead of an n, it's going to be 57.5 minus 54.5. Okay. To do my math on my calculator, 57.5 times 3 equals 172.5. And from there, I am taking away 54.5. And what did I get? I got 118. So these were congruent, right? Determine the measure of each angle. They are both 118 degrees. I'll put my little degree sign. And that's number 1. Number 2 says the measure of one angle is described as 12 more than 4 times a number. 12 more than 4 times some number. Its supplement. Remember that supplement means together they equal 180 degrees. Is twice as large. So when something's twice as large, it's 2 times bigger. That's supposed to be a multiplication sign. Find the measure of each angle in degrees. So here's what I'm going to do first. I'm going to say, all right, we have angle A and we have angle B. And together, these are supplementary, so they equal 180 degrees. Okay? Let's do this as angle A, and let's do this as angle B. So angle A, 12 more than 4 times the number. Okay? And angle B is just twice as large as that. So angle B is just going to be 2 times 12 more than 4 times the number. Okay? Because it's just twice as large as that first one. So I just multiplied the whole thing from that first one by 2. Now that I'm here, I can go ahead and solve. Okay. I am first going to distribute right here, just because that always makes things easier for me. 2 times 12 is 24. Keep my plus sign. 2 times 4n is 8n. Everything else stays the same in the whole problem. Okay, the next thing I'm going to do is combine like terms. 8n and 4n is 12n's. And 24 and 12, if I add those together, is 36. And there was only plus signs, so I just keep my plus signs. Equals 180. All right. Next thing I'm going to do is subtract 36 from both sides. I have 12 n's equals 180, take away 36. Do my math real quick. So 12n equals 144. I'm going to continue my work right up here. I will divide both sides by 12. I get n equals 12. 144 divided by 12 is 12. Now, I know what n is, but I need to find the angle measurements. So the first one I'm going to do is this first measure, which was the red one I did, A. So I have 12 plus 4n, and now that n is a 12. So 12 plus 4 times 12, 4 times 12 is 48. And if I do 12 plus 48, I get 60. So my first angle is 60 degrees. My second angle is twice as large as this. So I'm just going to do times 2. And 60 times 2 is 120 degrees. And remember, they were supplementary, so they should add up to equal 180. Is 60 plus 120 180? Yes, they are supplementary. So those are my 2 angle measurements, 60 degrees and 120 degrees. Number 3, a triangle has angles described as follows. The measure of the first angle is 4 more than 7 times a number. 4 more than 7 times a number. This is my first angle, angle A or whatever. The measure of the second angle is 4 less than the first. So that first one, take away 4. And the measure of the third angle is twice as large as the first, so times 2. What is the measure of each angle in degrees? So I have 3 angles, angle A, let's call it, angle B, and angle C. Now angle A is the one where I got the most clues. It says 4 plus 7n. 4 more than 7 times the number, okay? Second one, angle B, is 4 less than that first number. So it's going to be 4 less. So it's going to be 4 plus 7n minus 4. Okay? It's 4 less. The third one, angle C, is twice as big as the first. So it's going to be 2 times that first angle, which was 4 plus 7n. And altogether, this is a triangle, so triangles add up to equal 180 degrees. Okay? I'm going to go through and try to break this down a little bit and solve it. I'm going to distribute first. 2 times 4 is 8. 2 times 7n is 14n. This breaks down. I don't need that parenthesis anymore. And got everything else copied down. Okay, the next thing I'm going to do is I'm going to combine like terms. I have 7n's plus another 7n's plus 14n's. So 14 plus 7 plus 7. That gives me a total of 21 n's. Sorry, 21? Oh, 28, sorry. 28 n's. Everything else on here I can combine too. 4 plus 4, so I'm at 8 minus 4. Now I'm at 4 again. Plus 8. 8 plus 4 is 12. So I have 12 plus 28n equals 180. Again, that last step I just did, I just combined like terms. Now I'm going to take 12 away from both sides. I get 28n equals 180 minus 12, 168. And I'm going to finish solving right over here. 28n equals 168. I'm going to divide both sides by 28. I'm going to do this in my calculator because I don't have my 28ths memorized by heart. So this becomes 168 divided by 28, and that is exactly 6. So now I know what n is. I have to figure out what each of these angles were. Okay? And I'm going to be starting with my first angle, 4 plus 7n. So 4 plus 7n is now 4 plus 7 times 6. Okay? This becomes 4 plus, what is 7 times 6? 42. 42 plus 4 is 46. So this is my first angle. Okay, the second angle is just 4 less than that. So if I take 4 away, 46, take away 4 is 42. Okay? And then my third angle is 2 times this first one. So which is going to be 2 times 46. Do that in my calculator real quick. And I get 92. So these are the 3 angles that I get. How could I check? I could add them up. And if it makes a triangle, they have to add up to equal 180 degrees. So 6, 7, 8, 9, 10. Perfect. 9, 10, 180. It works out. All right, and you are finished with your exercises, your practice for this lesson. Basically, the only thing you have left to do is your exit ticket. So to just kind of summarize the main points from this lesson, you need to know a few things about geometry in order to write these equations. So use what you know to help you out there, okay? Writing an algebraic equation is so much easier than just trying to guess and check for these angle measurements. And so when we get into geometry, this is exactly what we're going to be doing. Sometimes it is easier to draw a diagram to help you solve the problem like I did in the very beginning when I was going over, you know, what these different angle names mean. So draw a diagram if you need help. But the last thing I want to make sure that you do before you move on to the exit ticket is just because you find an answer, just because you get to the end of your mathematical work and you get something like, okay, A equals 12, that might not necessarily be your answer to the question. So make sure you're reading the question all the way through and you're using whatever you do mathematically to get that answer. So a lot of the times you'll notice in the exercises before here that I had to take my answer, whether it was, you know, n equals 7 or n equals whatever, and then plug it into the original part of the equation that I created to find these different angle measurements, etc. Okay? So your exit ticket for today is only 2 questions. I'm going to read through them real quick and then you're going to get started. Okay? You're going to write an equation and solve the equation for both of these. Number 1, given a right triangle, find the measure of all the angles in degrees. If one angle is a right angle and the measure of the second angle is 6 less than 7 times the measure of the third angle. Again, you're going to need to write your equation out and then you're going to need to solve your equation and then tell me the measurement of all 3 angles in the triangle. Number 2 is also triangle 1. In a triangle, the measure of the first angle is 6 times a number. The measure of the second angle is 9 less than the first angle. The measure of the third angle is 3 times the number, more than the measure of the first angle. Determine the measure of each angle in degrees. Again, do your close reading. Figure out what you do know. Use those clues to help you solve. And then tell me those 3 angle measurements. If you get stuck here on your exit ticket, go back and watch how I did the exercises, because the exercises are very, very similar to this exit ticket here.